Hello students, 8 on the topic first law of thermodynamics. So first law of thermodynamics, it gives the conservation of energy principle. That means energy can neither be created nor be destroyed, but it can be transferred from one form to another form. So here in this chapter, the first law of thermodynamics relation for a closed system, it is explained here, and the concepts of the internal energy and enthalpy are defined here. The relationship between specific heat for gases is also derived in this first law of thermodynamics chapter. So here today we will study the first law of thermodynamics for a closed system. And this first law of thermodynamics for a closed system, it's for undergoing any cycle, it states that the cyclic integral of heat is equal to the cyclic integral of work. And it is this explanation, it is also called as the Joule's experiment. Comprises of the two processes. So this is the gas. So this is our system which is enclosed in the container, and this system, it is going through a cycle, and it comprises of two processes. So in first process, work is done on the system. Work is done on the system by this paddle wheel, which turns as the weight is lowered. So this is a pulley. So for this pulley, the paddle wheel is attached here, and some weight is fixed, or it is hanged over this pulley. So when this weight is lowered, when this weight is taken to the downside, then definitely this pulley is going to rotate. As pulley rotates, the paddle wheel also rotates. That means it is doing some work on the system. It is doing some work on the system, and that work is measured. And let the same system, so when this work is done on the system by this paddle wheel, definitely the temperature of this system, that is nothing but gas, the temperature of the system is going to increase here when work is done on the system. Now let the system returns to its initial state by transferring heat from the system. So when work is done on the system, the temperature of the system increases. So already we know that heat always flows from higher temperature to the lower temperature body. So when the temperature of the system increases, so when the work stops, then definitely the heat, it is going to transfer from the system to the atmosphere. That is, see here in this sketch I have shown here, some heat is transferring from the system. Heat is leaving the system. Whatever the heat is generated here, that heat is leaving the system here. So thus completing the one cycle. So you can see here, this is in this sketch I have shown here, 1A, 2B1, and 1A2B1, it completes one cycle. So here in this process, some work is done on the system, and in this process heat is the system, or heat is transferring from the system, and the system, it returns to its initial at the end of the cycle. one cycle. So when the amounts of heat and work are compared in both the processes, we find that the is always proportional. For that purpose, we are telling that the cyclic for a first law states that for a closed system, it undergoing any cycle, it states that cyclic integral. So it is symbol. It indicates cyclic integral of work will be equal to the cyclic integral of heat. See here, that only I have written here. First law states that for a closed system undergoing a cycle, the cyclic integral of heat is equal to the cyclic integral of work. So this is the symbol. So this symbol, it indicates cyclic integral or integration over the entire cycle. So if there are more than one, then we can write it in this form also. Summation of work over the entire change of state during which both heat transfer and the work transfer are involved, and the net energy transfer will be stored or accumulated within the system. So in here we have studied if the system is undergoing a cycle. Here we are studying if the system undergoes a change of state. Means here Q equals to amount of heat transferred to the system, where W is equals to amount of work done or transferred by the system during the process. So the net energy transfer, that is Q minus W, will be stored in the system, because some amount of heat is transferred to the system and some amount of work done, or it is transferred by the system. Work is done by the system during the process. That means the net energy transfer, that is Q minus W, will be stored the heat nor work, and is given the name internal energy. That internal energy, it is denoted by this symbol, that is delta E, or we can write it in this form dE also. So how we will write the net energy transfer? Q minus W will be equals to delta E. That is the energy in storage. It may be neither heat nor work, and this is called as the internal energy. So this equation I can write in this form also. Q is equals to this. If I will shift work to this side, minus W, it will be plus W, delta E plus W. Now we will study first law for a closed system undergoing a change of state. Or in the exam, he may ask, prove that internal energy is a property of the system. Now, this is sketch. So here we are having a C. So consider a system which changes its state from state 1 to state 2 by following path A. You can see here, consider a system which is changing its state from state 1 to state 2 by following path A, and returns from state 2 to state 1 by following path B. So the system undergoes a cycle here. You can see here 1A to 2B1. Here one cycle is completed. It is returning from state 2 to state 1 by following this path. Now 1A to B1, it becomes one cycle. So now writing the first law of thermodynamics, whatever you have written in the previous slide, writing first law for path A. For path A, how I will write now? QA. QA is equals to delta EA. EA indicates this is internal energy plus work done during this process by following path A. QA is equals to delta EA plus WA. This A indicates path here, path of the process. Let me call this equation as equation 1. Similarly, now writing the first law for path B, I will write here QB is equals to delta EB plus WB. Let me call this equation as equation 2. Now, the same we have written here. Now, the processes A and B together constitutes a cycle for which summation of work throughout the cycle equals to summation of heat transfer through the cycle. Now, summation of work throughout the cycle means work done during path A plus work done during path B equals to heat transferred during path A plus heat transfer during path B. It means during process B, during process A. This indicates path A and B. That is process A we may call work done during process A, work done during process B plus work heat transfer during process A plus heat transfer during process B. So now QA, path A I will make one side. So QA minus WA I will make A one side, that is process A, and WB minus, let me call EA. You can see here QA minus QB. If I will take here, and I definitely this will be minus delta EB. So let me put this equation as equation 4 here now. We have written uh, EA system returns from state 2 to state 1 by following path C, that is 2C1. How I will write here by as per the first law of thermodynamics, QC is equals to delta EC plus WC. Similar type of equations, but it is following path C here, or this equation is written for process C. Let me call this equation as equation 6. Now similarly, summation of work throughout the cycle equal to summation of heat transfer throughout the cycle. So WA plus WC equal to QA plus QC. Definitely QA minus WA. Similar type of equation I will write. WA I will shift to this side and QC I will shift to this side. QA minus WA. You can see here QA minus WA. It will be equal to delta EA only, delta EA. Then WC minus QC equal to minus delta EC. Now comparing equations 4 and 7. So in the first equation we have got delta EA is equals to minus delta EB. In this equation we have got delta EA is equals to minus delta EC. So comparing equations 4 and 7, I can easily write delta EB is equals to delta EC. That means energy is a property and the value of the property does not change unless the state of the system changes. Therefore, energy change of a system is zero if the state of the system does not change during a process. If the state of the system it does not change during a process, then energy change of a system will be zero.